Hello, everyone. Welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And I'm pleased to welcome Richard Lindzen. He is the Alfred P. Sloan Professor of Atmospheric Science Emeritus at the Massachusetts Institute of Technology, also known as Dick Lindzen. Dick, welcome to the Power Hungry Podcast.
Thank you. Pleasure to be with you, Bob.
Now, we chatted a bit before we started recording, but I warned you, I don't warn all my guests. I've given your title. You've been following climate issues for some time. If you don't mind, introduce yourself. Imagine you've arrived somewhere. I know you're in Paris. You're speaking to us from Paris. Imagine you've arrived somewhere in Paris or somewhere else at a party or something, and you don't know anyone, and you have about a minute to introduce yourself. Please introduce yourself.
Well, you have my name. That's the main thing. We're from the Boston area, grew up in the Bronx. I've spent almost my entire career in academia, but I started out as a I did my doctoral work and my master's and bachelor's at Harvard, although I started at Rensselaer and transferred to Harvard. I didn't particularly like Troy, New York. But in any event, I started in physics and realized that I preferred classical physics to modern physics. And that led me into applied math, where you dealt with fluid mechanics, mechanical problems, things like that. And so after getting my bachelor's in physics, I went to graduate school at Harvard in applied math. And applied math at Harvard was interesting in the sense that it really focused on application as opposed to the mechanics of applied math. And one of the popular topics at that time, and this was in 1960, was oceanography and meteorology, which were full of wonderful fluid mechanical problems. You know, hurricanes, how did they work? How did the wind systems work? And so on. And I did my thesis in that, working on the interactions of, excuse me, there's a phone call. Cut it for a moment if you can.
No problem.
In any event, it's the interactions of chemistry and radiation and fluid mechanics in the stratosphere. And there were a number of problems. And in some ways, I didn't successfully solve many of them at that time, but kept an interest in it and took a postdoctoral position at the University of Washington for a brief period, mainly to work with a guy called Dick Reed, who was a specialist in observations. Harvard was weak in that. It didn't have anyone doing that. And he was one of the major figures in observing something called the 26-month cycle. There's a very strange phenomenon. In the tropics, around, 15, 16 kilometers to 25, 30 kilometers. The wind blows from east to west for a year, turns around, goes the other way for a year. Average period is about 26 months. And that's far more significant than the annual or semi-annual cycle there. There's a question, what caused that? And that's something that I worked on for another year or so. And we, I think, successfully solved that problem. And then there was something else. Dick Reed was looking at tides in the upper atmosphere. And I had thought about that before. And there was an old problem from the 19th century, Lord Kelvin. We knew that tides in the ocean were lunar semidiurnal. And they were lunar semidiurnal because the tidal potential of the moon is actually greater than the sun because it's closer And so the change in distance as the Earth rotates was a much greater percentage of the gravitational field of the moon. And so you look at the ocean, excuse me, and the tides are semi-diurnal. The trouble was when you looked at the atmosphere, you looked at pressure oscillations at the ground, they're pretty weak, but the tides were semi-diurnal at the ground on Earth, but solar semi-diurnal. And that seemed to make no sense because the solar forcing is diurnal, 24 hours. And so there were suggestions as to why that was. And Kelvin suggested that the atmosphere was resonant at 12 hours. And that actually was the popular explanation for quite a few years until probably the 1950s. And then rockets soundings showed that didn't work. And so we showed that what was really going on was the 24-hour oscillation was being suppressed by a mechanism due to the rotation of the Earth. So, that was sort of fun and it was nice. I did some of this while I moved from Washington to Oslo, spent a year in Oslo, then came back to the States and took a job at the National Center for Atmospheric Research. And there was a reason for that. First, Boulder, Colorado is kind of nice. And I met my wife there, so that was pleasant.
It's worth
But
doing.
what happened in Colorado, I wanted to be out of academia when I saw my classmates who went into academia as assistant professors. And I had the feeling they were being abused. They had to teach a lot.
And this would be 60 years ago now. We're 19.
Oh, yeah. This was, 65, 66.
Right.
So I decided.
So if I'm sorry to interrupt, but what I wanted, you're giving a long explanation, which is fine. But I guess what the part that to me is so critical here is that you've been studying atmospheric interaction, atmospheric issues for now more than 60 years. That this has been your life work. But I think the reason that I was so interested in having you on, and we met in London at the Alliance for Responsible Citizenship meeting, was that you have been very vocal and very a prominent skeptic, or I would say is the right word, about the apparent or the much discussed consensus about catastrophic climate change. And so, can we cut to that if you don't mind? Because this is the part that I think is the where you have earned notoriety. You have earned some scorn from certain circles because of your belief that the catastrophic climate change
it's not belief.
is wrong.
I mean, look, let's face it, the existential threat hypothesis, narrative, has nothing to do with science. It doesn't even have to do with the UN's IPCC science. It's a complete political measure. It's bizarre. It makes no sense no matter how you look at it. And yet by constant repetition and certain modifications and a dependence on the ignorance of their audience and the quest for virtue signaling, it somehow has taken over. But, let me be more specific on that. For instance, for years, we were told, there are limits. Temperature has gone up about 1 degree in 150 years, another half degree in its curtains, and so on. People haven't the faintest idea what's being spoken of. If somebody tells you a half degree is going to set you to boiling, my first instinct is, can you patent that? I mean, it's stupid. And then you have people being told the Earth is warming. And you ask them, well, what the heck does that mean? How do you take the Earth's temperature? They haven't a clue. And so you peddle this for a while. From the very beginning, 1988, Senate hearing, Newsweek's cover. What did it say? Shows the earth on fire, and it has the byline, all scientists agree. At this point, hardly any scientists had ever heard of it. The bulk of the field of climate science, as it's called now, was tiny. There weren't that many institutes that studied it. Probably the major one was then the Soviet Union, the main geophysical observatory in what was then called Leningrad, today St. Petersburg.
Right.
I have a list of the prominent people at that point who thought this was nuts. And these were the directors of major labs, Scripps Oceanographic, World Meteorological Organization, European Center for Medium Range Forecasting. It wasn't as though everyone, quote, agreed. Quite a few, in fact, the majority didn't. When you polled the weathermen, as opposed to the researchers, in the 1990, most of them thought this was gibberish. But then you found out that the institutions had already been co-opted. Not entirely, but you found that the American Meteorological Society and the American Geophysical Union were all in on this. Part of the reason I think it represented an increase in funding, but whatever the reason, they were in. The National Science Foundation was in on this. There's a man, Alan Hecht, he was at a paleo, and all of a sudden, out of the blue, he said, we're into this global warming stuff. He went on, other professional societies that had no connection to climate were also in on it, which is very strange. The American Association for the Advancement of Science. I wrote a paper in 2000 or 1999, actually. No, it was 1989, called Some Coolness Concerning Global Warming. I sent it to Science magazine, and it was returned immediately. They said they weren't even going to review it. There was no interest in it. So I sent it to the Bulletin of the American Meteorological Society, and they reviewed it, published it, and the editor was fired immediately.
Really?
Yeah. But this became common. There was something called ClimateGate in the early 2000s, where somebody released the emails from the University of East Anglia,
right,
which was pushing this issue. And there were all these discussions with people like Michael Mann and so on, Phil Jones, about how to make sure that publications that questioned this did not get published.
Well, so I found your piece here, just to interrupt, Some Coolness Concerning Global Warming. You just wrote, what I'm seeing here is it's 2 pages. I guess it's actually an excerpt from an 11-page article. But as an admitted skeptic on this issue, I would like to discuss some aspects of that greenhouse hypothesis that leave me unconvinced and leave me concerned whether unanimity on such an issue is healthy for meteorology. So this is now 33 years ago that you were saying you've been very consistent on this. There wasn't some conversion moment with, I've had Judith Curry on the podcast where she was on side for a while and then realized, no, I'm on the wrong side, and changed sides, which is, in scientific circles, I guess is heresy. But you've been consistent on this now for more than 30 years, saying you never bought it from the first.
Yeah. I mean, there are all sorts of things wrong with it. But the main thing, and here's something I alluded to earlier. Its origin was in a very simple calculation done by Minabe and Weatherald. Now, it had been well known, actually, for a long time, since the 1930s, that the effect of CO2 was rather small. Doubling it was going to give you a little under a degree. And so didn't really cut much ice. I mean, people had proposed it earlier and so on.
Nice pun there. I like that.
Yes,
You worked that in. That's very, very nicely done.
But, then what Manabe and Weatherald found was if you took the main greenhouse substance, or one of them, there are two other greenhouse substances that are far more important than CO2, of course. One is water vapor, and the other is high-level thin clouds. Both of them are very strong infrared absorbers. CO2 is pretty small compared to these. But what Manabe and Weatherald suggested is if, for reasons that they never gave, if relative humidity remained constant, then the increase in temperature would lead to more water vapor. And this would constitute what they called a positive feedback that actually doubled the impact of CO2. And then the bandwagon continued. People assumed other positive feedbacks, not demonstrated or anything. And so you could make a model give you as much as you wanted. Now, as much as you wanted was still going to be 2-3 degrees. And I think a rational person would say, even 2-3 degrees, that's what I go through between breakfast and lunch. I survive that every day. But instead, there's an innumeracy in this. And so people just were told this is something to be scared of. And when pressed to explain why, there was an interesting explanation. And that is, if you go to major climate change in the past, let's say the ice ages, the glaciation, when you had 2 kilometers of ice over Chicago, or 50 million years ago in the Eocene, when you had alligator-like critters in where today you have Spitsbergen near the North Pole. If you asked what was the change in the mean temperature of the Earth, turns out it was almost entirely due to a change in the temperature difference between the tropics and the pole. In each of these special, extreme climates, the tropics was almost the same as today. But the temperature difference between the equator and the pole, or the tropics and the pole, I use them interchangeably because the tropics are fairly homogeneous in temperature within about 30 degrees of the equator. Was, today it's about 40 degrees. During the Ice Age, it was 60. During the Eocene, it was only 20. Now, if that is averaged over the globe, the change in the average temperature is only about 5 degrees. So, they say 3 degrees, it sounds very little, but it's almost as much as the temperature difference between now and the Ice Age, or the glaciation maximum, or 50 million years ago when you had no ice at all in the Earth. And so they said, well, that's significant, but what does that have to do with the greenhouse effect? Because it's dynamics that largely determines the temperature difference between the tropics and the pole. I said there's something called polar amplification. Whatever happens to the tropics is amplified at the poles. There was no basis for that statement. And as some articles by people who are modeling climate said, they didn't see, a lot of models didn't even have this.
Well, let's
Didn't show.
let's jump in there because you've talked about these differences and changes in temperature, and I agree with you completely on the idea of innumeracy. And this is one of the things I've talked about many times. That why have discussions about energy and power? Why are they so corrupted? It's because the general public is scientifically illiterate and innumerate. I mean, and that's just many analyses have found this. But let's talk about models for just a minute because a friend of mine, Chuck Spinney, worked at the Pentagon for many years and designed airplanes. And he had this all. He always dismissed models. It was like just spit out the word model like it was a dirty word, right? He just models. Garbage in, garbage out. Is that how much of this belief in models? Because let's be clear, we're just now at the end of the climate summit in Dubai, the COP28, and I don't know what the result of that is going to be. I'm assuming it's going to be a lot like the results from all the other climate meetings, which have been a lot of talk, but not much real action to reduce
No.
hydrocarbon consumption. But what is the fundamental problem with the models or relying too heavily on the models? Because isn't that
Oh,
the nut of the issue here about
don't
these models that show what might happen?
No. I mean, this is the irony of this subject. The models are not very successful. They all predict more warming than you see in retrospect.
So the hindcasting of the models that have been used have shown
Oh
that they're not
no,
accurate.
they've been poor. But here's the real nasty part of this. None of those models predict an existential threat. Even those models, however poor they are predicting, changes that would imply a 3% reduction in GDP by 2100,
Right.
when they're expecting the GDP to be more than double today's. So, this is not an existential threat. And to look for the models is to assume they're actually telling you that. The astounding thing about this issue is even the models don't tell you it's an existential threat. And without an existential threat, the measures that are being proposed and implemented are absurd.
Well, and this is one of the points that Bjorn Lomborg has made over and over is that if we're going to see a doubling of GDP over the next 50 years or 70 years, I forgot exactly what time frame he
Yeah,
uses. It's a decadal time frame. He said if we're expecting a doubling of global GDP, then these reductions that might occur because of climate change are
yeah,
relatively insignificant in the main scheme of things and better to get
absolutely.
richer quicker.
No, that's what Bjorn and Epstein and others, how shall I put it? When the public believes the science is settled, they no longer believe in science because science is never settled.
say
So,
say
as I
say that
pointed
again.
out,
Say that again. I like that. When the public believes the science is settled, then well, I'm going to say we're in trouble. But then science
then
doesn't
they're no
matter.
longer believing in science. I mean, this is something I've often mentioned. Science is a funny word. It's the only word I know of when you precede it with the definite article the becomes its opposite.
I like
Uh,
that.
and what I mean by that is science is a mode of inquiry. It depends crucially on falsifiability. You have to be willing to risk being wrong. By the mistakes, you improve it and find out what to do. The science is science as a source of authority. It's a very different thing from a mode of inquiry. On the other hand, in the political sphere, there is no question politicians envy the authority that science seems to have with the public. And so they're forever trying to co-opt it.
And
And
use
so
it
you
and
have,
use it for their political ends. So is it
sure, of
well?
course.
And so when you're saying that, what comes to mind, Dick, is this idea then of the science, of the scientist, to use your construction there, as kind of the modern priest somehow, the modern soothsayer, the modern witch doctor. I'm
Uh,
mixing things up
yes
here,
and
but
yes and no. I
okay.
mean, what happens is there are people in the sciences who take advantage of this, and they fit your description. I find most scientists are simply cowardly. And as long as their funding is there and they can publish and get promoted and so on, they're going to shut up or find a way of going along. So what I find, at MIT, a colleague mentioning why he went along, said, well, it's possible, isn't it? It wasn't that he was predicting it, he was trying to rationalize why he'd go along with it. My advantage was, I was sufficiently along in career that I wasn't that worried about funding and so on. Also, I'm a theoretician. Theoreticians don't need a lot of funding.
Because you don't need a lot of stuff. You can just think instead of having to have instruments or labs or whatever.
You can use other people's data, you can analyze it, you can do all sorts of things. But one of the things the personal computer does today is make computation readily available for many things. Perhaps not for modeling the whole atmosphere.
Right.
But you certainly can do theories of mechanisms. That was very important at one time. Still is, I think, actually. But, be that as it may, the issue itself, whenever you hear politicians saying they have science behind them, there's a big problem. Eisenhower identified that problem in his farewell address.
Right.
When he talked about the military-industrial complex, he also mentioned an academic government complex in science, where getting a grant substituted for actual achievement.
Right.
Now, an example of that I think is very revealing was the third Intergovernmental Panel on Climate Change Assessment, their report. And, they have one section dealing with science, that's Working Group 1. Working Group 2 and 3 just assume the science, they don't contribute anything on it. And many of the other things, the summaries for policymakers and so on, are written by bureaucrats.
Right.
So you have Working Group 1, it's 1,000 pages, it doesn't have an index. It's, like many of the things I'm discussing, for most people, it's reasonably unintelligible. And so they have a summary that emphasizes scary points. The summary comes out 6 months before the report, so the report has time to change to be consistent with the summary. That's the procedure. But they realize even the summary, which is about 20 pages, people are not going to read. And so they have their iconic statement.
Right.
And the iconic statement that year was, we're now pretty certain that most of the warming since 1960 is due to man. Okay. Now, that turns out to be not necessarily correct, but innocent. That is to say, that statement is most consistent with very low climate sensitivity and no danger at all. Okay?
Okay.
But they don't say that. They just tell you what the statement is. And Senators Lieberman and McCain, in bipartisan agreement, concluded this is the smoking gun. We must do something.
Right.
And, must do something will include funding. And indeed, when Clinton and Gore came into office, and even under Bush, the elder Bush, funding for climate increased by a factor of 15. And that was crucial. That created a whole new community that knew why it was being funded.
So just to repeat, so the global warming, the funding for climate science in general under George H.W. Bush went up 15x in that
No,
4 year period, or
actually,
from H.W. Bush through Clinton Gore.
right.
Okay, gotcha.
Over a period of about 3, 4 years.
Gotcha. Okay. So that the money becomes a key driver. But if can we just pause there for just a minute because I want to double back on before we started talking. I wanted to just review some of your personal history because I also have had Steve Koonin on the podcast. I've had Judith
Yeah.
Curry. I've had a whole lot of people who are on the other side who are, very interested in nuclear because of the threat, the possibility of climate change. So I've had people who are, I want to be ecumenical here.
I mean, climate is always changing. So, that is the issue.
Sure.
It's whether CO2 is doing it.
Right. But I, in reading up for and preparing for this interview, and we met briefly, we met in London at the Alliance for Responsible Citizenship conference, and I was privileged to sit next to your lovely wife Nadine at dinner, and you agreed to come on. But in looking at your history, you have had this just an amazing story, personal story. You're Jewish. Your family left Nazi Germany before the pogroms. What year did they leave?
It left 1938.
In the nick of time. And then I read your father was a shoemaker.
Well, not exactly. He
Oh,
was a
okay.
custom boot maker.
A custom boot maker. Okay.
Yeah. It's interesting. I mean, the reason I mentioned that to people was he was an observant Jew in Germany. Now, in 1933, when Hitler came to power, German universities got rid of everyone with Jewish blood, including people who had converted to Lutheranism, people who were Nobel laureates. One of them was Fritz Haber.
Right.
He converted to Lutheranism. He was the inventor of their poison gas during World War I. He was a Nobel laureate.
The Haber-Bosch process was his process as well, right? Yeah.
They got rid of them. When my father died, this was, early 80s, I looked at his papers. He was admitted to the Guild of Bootmakers in Dortmund, Germany in 1936. And it always struck me that this suggested a profound difference between academics and bootmakers.
How so? What do you mean? I don't follow.
I mean, whereas the academics got rid of Jews before Hitler even asked, bootmakers were admitting them to the guild long after Hitler was in.
I see. Well, so but
perhaps it represents a greater valuation of bootmaking.
that they actually make something worthwhile then. Yeah. So, but do you ever think about I mean, you're 83 now, if my research is correct. It's a pretty incredible life you've led, that you were born in the US to immigrant parents. Your father was a bootmaker, and yet here you as an immigrant Jew in the United States go on to have this incredible career. I mean, to me, incredible career. I mean, do you ever look back at that and think, damn, I'm a lucky son of a bitch? Really, or how do you think about that?
I've never really thought about it much, to be honest. Let me put it to you bluntly. I went to school in New York at a time when, if you were a bright kid, they identified you. You were not pushed particularly, but by the time you reached junior high school, they had the so-called special progress classes. And so you finished the 3 years in 2. Places like Bronx Science were competitive exams. It was very much a meritocracy, like France still is to a certain extent. And so people encouraged you, and you enjoyed it. And you didn't think, how remarkable is it that we did it. you had colleagues who were in the same boat. Bronx was full of kids whose parents were not academically accomplished, who were admitted to elite schools and got scholarships. And there was the Regent Scholarship. You had schools at that time like Cooper Union at the college level that were highly selective. Even City College, where probably most of the graduates of Bronx Science went. And indeed, when I taught at Harvard, the single most common point of origin for the faculty in the Division of Applied Science was probably the Bronx.
And, well, it's remarkable because if memory serves, Steve Koonin is from the Bronx as well. And I mean, he's definitely from New York. Maybe he's not from the Bronx, but do you recall that off the top of your head, or do you know Koonin?
Yeah, sure.
Yeah. Well, so how do you explain, and we're in an era now where unfortunately there is a rise, I think very clearly, of anti-Semitism both in the US and around the world. It is though, how do you think, you didn't think about your own origin story so much, you just said, but it is truly stunning in some ways when you look at the impact that the influx of Jewish immigrants into the U.S. Before World War II and the commencement of the U.S. and getting in World War II, and then after World War II, how their enormous impact they've had on the arts and sciences in America and around the world. How do you think about that? Have you thought about that? Because it is an outsized influence.
It's, every group has different priorities.
Yeah.
Among Jews, education was always a high priority. Groups differ in skills, in instincts and preferences and so on. And so, especially after, remember in Europe, at least, Jews were marginalized until the French Revolution.
Right.
And so, this was sort of releasing a group that even in their internal dynamics gave great importance to studying.
Mm-hmm.
Initially, it was religious texts and so
Right.
on.
Right.
But when the world opened to people like that, these same skills were advantageous. And, there were other things that occurred in France, for instance. Jews in Alsace, when France took it, they had expelled their Jews, but then they militarily took over an area that had about 20,000. And they were in the horse trade. And so the cavalry needed them.
Uh-huh.
And they became wealthy and played a major role in the industrialization of France.
Huh.
There were others who came to Bordeaux. In a way, it's, the discrimination and the problems probably had the benefit of kind of selecting people to survive.
And giving more motivation to make them
Sure.
succeed. Yeah. Interesting. I met a guy with the Alliance for Responsible Citizenship conference in London who was a Ukrainian Jew. He was Dmitry. I've forgotten his last name. He made Jordan Peterson's suits, and they were very well made and handmade, right? But he was a Ukrainian Jew who'd immigrated a couple places. Now he's in Estonia. But he said the thing that I tell my kids, or I teach my kids, you have to be able to make money, right? That we're Jews. We might not be here for long. You have to learn that. And it was just a very kind of matter of fact, but it rhymes just a little bit with what you're saying, that there was that motivation that the discrimination created is a source of the motivation.
I think New York, with its specialized schools,
mm-hmm.
Did a good job of detecting talent where it was and promoting it.
Well, you said Bronx Sciences before we recorded was harder than when that was more challenging than when you got to university. Is that true?
Not so much more challenging, more stimulating.
What's the difference?
The people.
Huh.
I think it was probably a much brighter crew per class than Harvard.
Huh. That's interesting. Well, so let's jump back. I just wanted to cover that because I just, well, as I've said from an outsider, right? I'm 20 years younger than you are, but my life has been fairly pedestrian compared to yours. I mean, you've had a remarkable career and a remarkable family story. What do you think of the term? And this is something I talked about with Steve Koonin, who, of course, wrote the book Unsettled, which has had wide acclaim and sold
Yeah.
many hundreds of thousands of copies.
And, remember his point, I mean, is that the accepted narrative science does not promote the notion of an existential threat.
Right. What do you think of that? What do you think of that? It was a question I put to him. Well, what do you think of this term denier? Because it was something I put to him because, that's something that you can't, has a loaded meaning when it comes to
Of course it does.
Nazism and the
that
rest
was
of it.
fully intentional.
How
It
so?
was meant to identify anyone who questioned Al Gore as a Holocaust denier.
And how do you,
repulsive.
Sorry to interrupt. You said it's repulsive.
Yeah, sure. I mean, most of my family died in the Holocaust.
And yet it's been used as that label has been used.
It's thrown around by clowns
to denigrate anyone who strays from the orthodoxy.
Sure. And they don't even know what the orthodoxy is.
Well, so this idea around science as you wrote in a paper with Will Happer in 2022. You said the IPCC, I'm quoting here, is government controlled and thus only issues government opinions, no science, which provides no real science supporting the rule. This was a rule around greenhouse gases. So when you say and we've talked around this, but can you talked about this a little bit? But when you say there's no science to support this catastrophist narrative, how did you boil that down in the simplest terms? When you say there's no science,
there is, of course, some science.
Okay.
I would say that Working Group 1 is told not to criticize models too much. But there's a natural tendency, I think, among scientists not to wish to say things that are patently absurd. And so, for instance, it will say, we are terrifically uncertain about the role of clouds. But they might not emphasize that this could destroy their whole picture.
Right.
And once you get outside of Working Group 1, it really is divorced from science. It is trying to promote the urgency. But, the science in it, however biased, does not support the urgency. And that was Steve Koonin's point.
Right.
That not only is there uncertainty, which Judith Curry pushes and so on, but that there's no evidence for urgency.
Well, so then let me follow up on that because so what should we do then? What is the best? I posited that the best no regret strategy as we look at the future is natural gas to nuclear, that this is a no regret strategy because both are in abundance. They're low carbon. They can scale up and
there's a simple best strategy.
And what is that?
Forget about decarbonization and do everything necessary to make your societies as prosperous as possible. And that's perfectly obvious because if you look at CO2, if you believe it's terrible, you notice that nothing we've done, and we've already spent trillions of dollars, has had the least impact on its rate of growth. So if you think it's a big problem, and what you're doing is not changing the situation, the only thing you're doing by raising the prices, curbing energy, all these things, is reducing the resilience of your society. And that's sadistic. And the question is, why are people doing that? And I think the answer is pretty obvious. And it's the reason why the environmental movement since Earth Day, first Earth Day, has always emphasized the energy sector. The energy sector involves trillions of dollars.
Right.
Any major change to it will involve trillions of dollars. And so, what is the implication of that? Well, if you're going to spend trillions of dollars, somebody will get them.
Right.
Or some group will get them, or they'll be distributed. And all it takes, I figure, if you're talking, I mean, and I think the so-called Inflation Reduction Act involves $9 trillion for climate-related issues. You take 2% of that, and that's about enough to fund generously the campaigns of virtually every elected official in Washington.
So it's all about the money. It's not about climate.
Money plays a big role in it. And it strikes me in America, and it's a long time, not just this issue, the huge disparity between the industrial economy and the political economy.
Right.
What I mean by that is it takes only 2% to fund the political ambitions of the people who are determining that $9 trillion.
You know, I'm glad you brought that up because I've been thinking about this myself and thinking about what's happened at COP. And as you may recall, it's a famous essay that was written by C.P. Snow, the British writer in the 50s, the two cultures, right? And I've thought about it a lot lately because I travel in rural America and I meet farmers, I meet ranchers, and they deal with the real world. They deal with the physical thing, right? They grow things, they make things, they build things. And I love those people. I mean, I'm all about it, right? I love those people because they talk about what's the price of beef? What's the price of wheat? What is this, but they're so far removed from the consuming class or the political class. C.P. Snow talked about the gulf between the sciences and the humanities, but you're talking about the industrial economy versus political economy. I think of it as lawyers versus engineers. Is that
Sure.
is that the right way to think about it? Or you said industrial versus political. How's another way to think? What's another way to think about it?
No, I think you're right. I mean, for instance, with this global warming narrative, if I describe to you how the greenhouse effect works, how the climate regimes in the earth, the fact is the earth has dozens of climates and they all have different time behavior.
Mm.
They don't march in lockstep with this funny metric that people use. But as soon as I describe it, I think for the most part, eyes glaze over.
Right.
On the other hand, if an Al Gore tells you that the greenhouse effect is like a blanket and the blanket keeps you warm, that is satisfying. You don't have to think much. A blanket keeps you warm. You understand that and so on. If you try, say, the Coriolis force due to the rotation of the Earth determines the different tropical and mid-latitude climate regimes, how are people going to respond? Who knows what the Coriolis force is?
Right.
So you get that. The extreme version of that was John Kerry in Indonesia gave a talk which was recorded, where he says, we all know how hard physics and chemistry can be, but climate science is so easy, any child can understand it. I mean,
right.
And I think
But
that's the level of his understanding. I mean,
right. Well, and John Kerry is a lawyer, right? And President Biden is a
yes,
lawyer. I've been looking this up. President Biden is a
yes.
lawyer. John Kerry's a lawyer. Jennifer
Oh,
Granholm is
yeah.
a lawyer. We are ruled by lawyers, right? That we live in a system
Yeah.
that lawyers are in charge. There are what, 55 lawyers in the Senate and one engineer.
Yep. And a doctor or two.
And a doctor or two. Let me just ask about the issue of clouds, because you've talked about this and water vapor. That
Yeah.
is, why is it so hard? We talked about models. Why are those so hard to include in models? What is it about those things, the
Well,
water
they
vapor,
are
that
included. I mean, there are certain misconceptions. I think people saying they didn't include clouds and so on. In the original Monabian Weatherald, it was a very simple model, and clouds were fixed. So that was nonsense. One of the problems in nature, for instance, as opposed to a one-dimensional model, is if you look in the tropics and you look at water vapor, it's not mixed. There are areas that are bone dry and areas that are almost saturated. Then you have the clouds. The clouds, the upper level clouds, are very variable. So it's not one thing, it's not homogeneous. And you have to keep track of this variability to know what the feedbacks are.
I see.
That's been an issue. I wrote another paper that I put in the bulletin 10 years later, this was around 2000, on what we called the iris effect. And this was at a time when NASA was still reasonably open-minded. They had a administrator, a man called Griffith, who was himself skeptical, and he was told to shut up about it. But I was consulting at NASA at that time, and I had two colleagues, Arthur Hu and Ming-Da Chao, and they were much more conversant than I am with satellite data. And so we were looking how these upper level clouds responded to surface temperature. Now, why is there a connection? Well, the surface temperature plays a role in the generation of these cumulonimbus towers. And the upper level clouds come from the water vapor that is thrown off of these clouds as they just rise rapidly. And what we noticed in the satellite data, it took geostationary data for that for certain reasons, is that when the temperature warmed, the extent of the upper level cirrus diminished, letting out more heat and counteracting the warming temperature at the bottom. And so this looked like a pretty strong negative feedback. And I think, it's been over 20 years since we published it. And I think the theory is still viable. We have a review of where it stood that we published about a year or two ago. Published it in a South Korean journal, the Asian Pacific Journal of Atmospheric Sciences. Publishing it in American journals would have been almost impossible. But the original paper was in an American journal, Bulletin of the American Meteorological Society. And again, the editor was fired immediately for letting it through. And the new editor immediately called for papers to criticize ours.
Right.
And didn't allow us to respond for 6 months. And this was ludicrous. I mean, we eventually answered all of them. And some of the funniest of them, I won't name the author, he found something that he thought we had done differently from the way we should. It turns out the way he thought we should would produce a stronger negative feedback. So he assumed any difference would have made it worse. It was the contrary. In any event, that's the way things stand. Today, more commonly, what happens, and this happened to Will Happer and others, they'll submit a paper and someone will review it and say, except with major revisions. And the major revisions are designed to keep you busy for a year, at which point they reject it.
Right.
And that prevents you from putting it in another journal or something. So, this is going on. It's pretty ridiculous. And it's, it was an early example of cancel culture.
Well, so is this when you're talking about this, and we're coming up on an hour, and again, my guest is Richard Lindzen, Richard Dick Lindzen. He's the Alfred P. Sloan Professor of Atmospheric Science Emeritus at MIT, and he has been studying atmospheric issues and climate for over 60 years. Is this orthodoxy, or let me ask the question directly, this orthodoxy around the science, to use the way you formulated it, is it just dangerous? Is it, how do you think about it? Dangerous is kind of not the
Horribly dangerous.
Horrible. Okay.
It's like, the art of war, Sun Tzu. Somehow the Western world, the Europe, Western Europe, the Anglosphere, are being encouraged by energy policy to commit suicide. And it's odd, but China is, of course, manufacturing all these renewable devices, quote, renewable. But I even found that China was sending messages to our students, offering prizes for papers promoting alarmism. They weren't big prizes, but I mean, it's curious seeing this come out of China.
Well, and it goes hand in glove in some ways with Russia trying to limit hydraulic fracturing in the West, right? There's very clear that Russian money was involved in trying in funding anti-fracking groups in Europe. You have now still 8 countries in Europe that have bans on hydraulic fracturing, including the UK.
Yeah.
So what hurts if I'm paraphrasing you correctly, by implementing or fomenting these kinds of catastrophist narratives in the West and the Anglosphere, this helps Russia and China, our enemies. Is that a fair way to read it back to you?
Of course, why waste weapons and engage in war and have your own people get killed when you can cause your opponents to do themselves in? And we see this with the climate issue. I mean, the measures taken are hurtful to people. They're inflationary. In Sri Lanka, they cause starvation. They're destroying agriculture, and that's a whole other story because that's so nonsensical, even compared to CO2.
Right.
But you have an enthusiasm for the exercise of this power among particularly stupid politicians.
Well, and I have a hard time disagreeing with you. And I just want to read one paragraph you sent me after I published a piece on Substack. You graciously sent me this response, and it was on my piece that I published called "Bone Chilling" about the potential of New York to run out of natural gas. I just want to read it because we talked around this, but you wrote, "Net zero is premised on the assumption that added greenhouse gases are an imminent existential threat that justifies any actions. As it turns out, even if the EU and Anglosphere shut down completely, would have no discernible impact on the rate of increase of greenhouse gases. Moreover, none of the official assessments, however biased they may be, project anything like an existential threat. One obvious impact of current policies is to reduce the resilience of society to natural disasters, whatever their cause. In essence, net zero, claiming to avoid a grotesquely improbable catastrophe, is paving the way for many very likely catastrophes. The following," you're referring to my article, "describes just one of them. It's hard to understand the current political enthusiasm for what amounts to societal suicide."
Yeah. My concern in a deep sense, I mean, I realized what was going on more directly. Somewhere around 10 years ago, I mentioned the IPCC Working Group 1. They always correctly pointed out that they couldn't find any significant correlation between extreme weather and their climate index.
Mm-hmm.
Okay. And yet, 10 years ago, the proponents of climate alarm decided that they wanted to say extreme weather is the proof of climate change.
Right.
And why did they do that? Because they realized that the visuals, first of all, extremes occur virtually every day or week someplace. And today you will get visuals of the extremes. There will be drought, flood, this, that, windstorm. And you make visuals, and visuals are very good for promoting emotional responses. And they decided to move from the index and from the half degree to the pictures of extreme weather so that people would get more excited. And that was a dead giveaway that science didn't matter. It was a propaganda issue, and they wanted to promote as much fear as possible. And of course, they've begun it for at least 30, 40 years in elementary school, teaching kindergarten kids the end of the world.
Right.
And by now, the first generation that's been indoctrinated are CEOs. I mean,
And so they have to toe the line.
they don't have to toe the line. They've been inculcated.
Right. Gotcha.
Yeah.
So we've been talking now for just over an hour, Dick, and so I want to respect your time, and I always like to
okay.
a couple of just quick. So if you a quick response on this one, if you don't mind, and then I want to ask you what you're reading and what gives you hope. But what excites you? And you've been, I'll say it. I'm not going to fear of insulting you. You're an old man. You've had a long career. You know, you're in your 80s. When you look at the world of science and technology today, what excites you? AI. What interests you these days? What?
AI is fascinating.
Uh-huh.
I mean, it'll be interesting. I was discussing it with friends. It's already pretty good at proving mathematical theorems.
Mm.
We're wondering, from the point of view of music, should be able reasonably soon, if you play it a recording of a symphony, to write down the score and the instrumentation.
Wow.
It's fascinating. Of course, one can imagine its misuse.
Right.
But it certainly will be interesting to see where it goes. For much of the rest of science, as opposed to technology, things have been rather stagnant for a long time.
Mm.
Biology is active in some ways, but if you think back, the double helix and so on, it's from the 60s.
Right.
In physics, we're still using the standard model from the 60s. I often have the feeling that one of the things that may have slowed down science, and part of it is natural, of course, there are periods like that, but was Sputnik.
Huh.
Sputnik encouraged us to recruit more and more people into science, into STEM.
Mm-hmm.
And it's perhaps a matter of dilution. And, peer review is post-World War II. And that was a pressure for groupthink.
Right.
And then I look at a picture of something called the Solvay Conference in 1929. It's a photograph of all the world's physicists. And it all fit in one photograph. And it was a golden age for physics.
Right.
So, I'm not sure that we have optimized progress in science. And as a result, even with transistors and so on, they're a product of the 50s and 60s.
Sure.
And photolithography, which is important in making chips, is
Right.
from then.
Sure.
So, we're working off that
Still.
quite a lot.
Right. So last two questions. What are you reading then? What's on the top of your book list?
Not much these days. Email is just swamping me. I mean, I get about 600 a day.
600 a day. Wow. I get
Yeah.
a lot. I don't think it's 600, but that's great.
It's
Okay.
just absurd. But, I actually decided to read the diversity myth this week from Saxon Peter Thiel,
Uh-huh.
who, it's interesting. I mean, a number of years ago in the 90s, they were worried about what was essentially the predecessor of DEI at Stanford.
Right.
And I've wondered about that. I mean, as soon as George Floyd died, almost instantaneously at all universities in America, you had DEI bureaucracies ready to go. And you mentioned anti-Semitism, and it's perfectly obvious that DEI has played a major role in promoting anti-Semitism.
Huh.
Because, it divides the world into oppressors and oppressed. Oppressors are always wrong, oppressed are always right. And then it decided Jews are white affiliate.
Right.
And, this is interesting vis-a-vis Israel, where a majority of the population is from the Arab world. And you also have 100,000 Ethiopians.
Right.
And they're all white affiliates.
So last
But,
question then, Dick. So just in the interest of time. So what gives you hope then? We've talked about some things that are fairly depressing and kind of the orthodoxy and around the lack of, or the overwhelming groupthink in terms of response and net
You're
zero.
asking a tough question.
Well, that's why I get paid the big money here. Lindzen,
no, but I mean, it's hard to be optimistic at the moment. And I think a lot of us feel that the only things that will get us out of this rut will be the damage that is done by the policies imposed, including energy. And eventually people will be so upset they will rebel.
Yeah.
There aren't too many trends at the moment that actually give one much encouragement.
Yeah.
And, I guess the most hopeful thing I always feel is we're never good enough to identify all the factors, and there may be some degree of freedom that will work us out of this. I haven't identified it.
Well, yeah. Well, it is. So we live in sober times, or there are a lot of sobering things that are happening, including, of course, the war in Israel and now in Ukraine and all these other conflicts. But
and Iran's nuclear efforts, and so
it goes on. Well, listen, it's been a pleasure, Dick. It was a great pleasure to meet you in London.
Good luck with your podcast.
And great to meet Nadine. Please give her my regards.
I will.
Again, my guest has been Richard Lindzen. You can find him. He's easy to find on the Google. He's written prolifically on energy and climate issues, or climate issues now.
People are free to email me.
And people are free to email me. Email Dick. He's easy to find. Dick, thanks a million for being on the Power Hungry podcast. It's been great fun.
Okay. Take care. Bye-bye.
And all of you in podcast land, thanks for tuning into this episode of the Power Hungry podcast. Until next time, see ya.